In this video, we'll try to understand how to draw cam profile. Now we have to draw a cam profile in case of a knife edge follower using the following data. Minimum radius of the cam is 5 centimeter. Then outstroke is 120 degree with simple harmonic motion. Outward dwell is 60 degree. Return stroke is 120 degree with simple harmonic motion and dwell for the remaining period of cam rotation. Stroke or lift of the follower is given as 6 centimeter. So the data is written over here. So outstroke is 120, outstroke dwell is 60 degree, return stroke is 120 degree, and remaining angle will be return dwell, that is 360 minus the summation of all these three particular angles. So it is 360 minus 120 plus 60 plus 120. So that will be nothing but 60 degree. Lift or stroke of the follower is given as 6 centimeter and minimum radius of the cam is given as 5 centimeter. Now the important part is to select the scale over here. So scale that we have chosen is 1 centimeter is equal to 20 degree on x-axis of cam rotation. Then 1 centimeter is equal to 1 centimeter on y-axis of lift or stroke of the follower. So outstroke is equal to 120 degree. So 120 divided by scale that we have chosen is 20 degree. So it is 120 divided by 20, that is 6 centimeter. Similarly, theta OD is equal to 60. So 60 divided by the scale, that is 20 degree. So it is 3 centimeter. And theta R, return stroke angle, is 120 divided by 20, that is 6 centimeter. So on our displacement diagram, we are going to represent these three particular angles which are required for the displacement diagram as 6 centimeter, 3 centimeter, and 6 centimeter. Similarly, on y-axis, 1 centimeter is equal to 1 centimeter. So on y-axis, 6 centimeter stroke will be representing by the original length of 6 centimeter. So let us first draw the diagram for this, displacement diagram for this. So we have considered the 6 centimeter length of the outstroke, then 3 centimeter length for the outstroke dwell, and then the 6 centimeter length for the return stroke. So outstroke is 120 and by scale it is 6 centimeter on our displacement diagram. Outstroke dwell is 60 degree. It is by 3 centimeter on our displacement diagram. And return stroke is 120. So it is 120 divided by 60, that is 6 centimeter on our displacement diagram. Then we are not considering this particular theta return dwell part over here. So we are concentrating only on these three particular angles for drawing the displacement diagram. Now we'll draw the center line. Now as it is a simple harmonic motion, we'll divide this particular semicircle into 6 equal parts. So it is 180 divided by 6, that is 30 degree. So we have drawn the angles of, we have marked the angles of 30 degree over here. Now draw the lines passing through this. Then mark this 1, 2, 3, 4, 5 and 6. Draw the horizontal line from this one till it intersects this vertical line from 1 at this particular point. Similarly, draw a horizontal line from 2 till it intersects this vertical line from 2 at this particular point. Same procedure we have to draw for line from 3 till it intersects this vertical line from 3 and so on. Now we have to join these particular points by a smooth curve. So this is the simple harmonic motion curve that we have obtained for theta O is equal to 120 degree. Now as both, that is the outstroke and return stroke, they are of the simple harmonic motion, we can transform these particular points or we can translate these particular points on the return side also. So as you can see over here, the similar points or same points will be there for the return stroke also. And then join a smooth curve from this particular point. So this is the curve for return stroke. And then this is the dwell. So we have completed this our the displacement diagram in case of this particular problem. Now we'll draw the cam of 5 base circle of 5 centimeter radius, and then we'll divide, taking this particular vertical line as a reference. We'll divide the given particular base circle in 6 equal parts of 20 degree for our outstroke, because our outstroke is of 120 degree. So 120 divided by 6, that is 20 degree. So these are the lines which we have drawn of 20 degree from the center of this particular circle. Then remaining 60 degree is for dwell. So from 120 to 180, correct? Or this is the 60 degree angle which we have drawn over here. Then we'll draw the lines for the return stroke, which is also of 120 degree. So these are the lines which we have drawn for return stroke. So it is from this 0 to 6, these are the parts for our outstroke. Then this is the 12, and this is our 6 to 12, these are the return stroke part. So as we know that this particular is theta O, then 12, and then there is a return stroke. Now we'll transfer this 1A distance over here on this 1A, then this 2B distance from 2 to B over here on this line, then from 3 to C it will be on this particular line, and so on. So first we'll measure this particular distance. As you can see, we have measured this distance. So we have drawn this line over here. So this particular distance we have to mark over here. So we'll be marking that particular point. So it is 1A distance is marked over here. 1A distance is marked. Similarly, we'll now draw, or we'll mark this distance 2B over here. So this is 2B distance as indicated by this dark line and this 0. So that we are marking over here. So this is 2B distance. This 2B distance is marked over here. Similarly, this 3 and C distance, that is 3 centimeter, that we are marking over here. That is 3C distance. Similarly, for 4D, then for 5D, and then for this particular 6F. Similarly, this 6F will be drawn on the return stroke lines also. So all these particular points are drawn. So it is 6F, then 7G, 8H. So all these lines 6F, 7G, 8H, these distances they are transferred over here on the corresponding lines. Now we have to draw a smooth curve passing through these particular points, and that will be our cam profile. So as you can see over here, this is the curve cam profile that we have drawn. This is the dwell period, and so this from 0 to 6 it is the outstroke. Then there is a dwell from F to F, and then from F to this particular L part, correct? It is nothing but what? The dwell, and then it is nothing but the return stroke, and then there will be a dwell period of 60 degree. So that will complete our complete cam profile. So in this way we can draw a cam profile in case of this particular knife edge follower having simple harmonic motion during outstroke as well as during the return stroke. Thank you very much for watching.